Alright, in this question we're asked to calculate an angle, angle C. I want to focus in on triangle ABD because I notice right away we're given an angle and the two sides that contain that angle, which means I can use my cosine law to calculate the common side. I marked it as an x. Labeling the sides, I get A here, B here, and D here. Using the cosine law, I have a squared equals b squared plus d squared minus 2bd cosine of angle A. Substituting in what I know, side B is 10, so it's going to be 10 squared. Side D is 8, so it's going to be 8 squared minus 2 times 10 times 8 times the cosine of 60 degrees. I'm going to pull up my calculator and start off by going 10 squared plus 8 squared minus, I want to put this into brackets, so it's going to be 2 times 10 times 8 times the cosine of 60. And now I can close my bracket, hit equals, and now I know that a squared is going to be 84. I can take the square root of 84, and now I know that a is going to be 9.2. Now I can turn my focus to triangle BCD. And because I know that this side is 9.2 and I'm looking for the angle that's opposite 9.2, I'm also given angle B as 40 degrees, and I do know side B, so I can use my sine law this way. I'm calculating an angle, so I want to go sine of B over B is going to equal sine of C over C. Substituting in what I know, I have sine of 40 degrees over 6 is going to equal sine of C, which is theta, over 9.2. We just calculated that. Cross multiplying, I get 9.2 times the sine of 40 degrees over 6 is going to equal sine of theta. Let's pull up our calculators, and we're going to go 9.2 times 40 sine equals divided by 6 equals. So now I know the sine of theta is going to equal 0.9856. I want to find out what theta is, so I'm going to use my sine inverse function. So theta equals 80.3 degrees. All right, let's move on to the next question.